Hello everyone, welcome back to a new video on web security challenges. So today we have an intriguing lab in front of us, which is file paths reversal with absolute path bypass. So this lab stimulates a real-world scenario where a website has a vulnerability in a way it handles the file paths, allowing the attackers to access sensitive files on the server. So let's dive right in. So in this lab we are dealing with the path traversal vulnerability in the product image display functionality, and the application is designed to block traversal sequences but treats the supplied file name as being relative to a default working directory. And our goal for this lab is to bypass these security measures and access the contents of the sensitive file /etc/password. So as you all know, the very first step to solve any lab is to access the lab. So I will just click on Access Lab. Now before we proceed, let's talk about the payload. So in the context of web security, a payload is essentially the data you send to a web application to trigger a specific behavior, and in this case our payload will involve manipulating the file name parameter in the request to fetch the etc/password file. So here is how we can solve this challenge step by step. First of all, I will just open the image in new tab. We will use burpsort, which is a very much powerful interception proxy to basically capture and modify the request that fetches a product image from the server. Now within burpsort, we locate the file name parameter in the intercepted request and we /password, and by doing this we are essentially telling the server that we want to access the /etc/password file. So after sending the modified request, we observe the response. So here you can see that the server is vulnerable to path reversal, and it provides us with the contents of the /etc/password file, which includes the user account information. So now you might wonder, why does /etc/password work in this lab scenario while something like /etc/password does not? So let's break it down in a script-like manner for a clear understanding. So basically, path traversal vulnerabilities often occur when an application fails to properly validate the user input, allowing the unauthorized access to sensitive files, and in our lab case scenario the application is designed to display product images but it lacks the proper validation. So in a path traversal attack we attempt to navigate from our current directory to sensitive files, and the // notation is an attempt to traverse upwards in the directory structure. So logically // etc/password should work right, but well, it does not always work. So here is the catch: the server application interprets the paths based on its own context, and when we use /etc/password the application treats it as a path relative to its default working directory. So in other words, it automatically considers that we are asking for a file named password inside the /etc directory within its own file structure. So now when we use /etc/password the application might interpret this as a path attempt to go up 3 directories, but it still starts from its designated root directory. So if the application does not allow traversal outside of its root, no matter how many // we use, it won't escape the predefined boundaries. So in our lab scenario, // etc/password fails because the application security context restricts it within its root directory, but when we directly specify /etc/password it is treated as a file request within the application's context, granting us the access. So the key lesson here is understanding the application's perspective and limitations. In the real world, secure coding practices and input validation are very much crucial to prevent these kinds of vulnerabilities, ensuring that even complex traversal attempts are prevented. So in this lab we have successfully exploited a path traversal vulnerability by crafting a payload that allowed us to bypass security measures. It's a stark reminder of the importance of secure coding practices. Always validate and sanitize user input to prevent such vulnerabilities in real world applications. Thank you.